Okay, so thanks everyone for coming. It gives me enormous pleasure to introduce Professor Karishma Choudhury, head of her inaugural lecture as chair in behavioral modeling. So Karishma reminded me this week that the first time I met her was in MIT in 2004. So I looked back at my photos, and if you had delayed your inaugural by one more week to the 29th of October, it would have been exactly 21 years ago. At the time, Karishma was a master's student with Moshe Ben Akiva, and she was the senior student in the lab. So she had the special desk, which is a desk right at the entrance. Now, of course, Karishma deserved the special desk, but for the PhD students here, you should appreciate that at ITS, all PhD students are equal in terms of their desks. At the time, I was doing my PhD at Imperial College. And so Karishma and I were chatting, and she told me about her fiance, who had just started his PhD at Imperial. So a week or two later, when I was back in the UK, I also met Zia. I never thought that 21 years later, I would be here at the joint inaugural lecture. So it's an enormous pleasure. Karishma and I stayed in touch. We wrote a book chapter together eventually, but didn't really collaborate very much until a few years later, Zia was interviewed for a position at ITS. At the time, Andrew Daly was still here, and he told me we have to do everything we possibly can to get Karishma to also join us in Leeds. Then I had a meeting with Moshe for some reason, and Moshe said, make sure Leeds knows how good Karishma is, as if there was any doubt. I never had any doubt about the contributions Karishma would make to ITS, to the University of Leeds, or to the travel behavior research community more widely, but she exceeded all of those expectations. I asked Karishma also yesterday how long she had been at ITS, and she said 12 years and 9 months. Importantly, she did not say too long. In those 12 years and 9 months, Karishma has published over 70 journal papers. She has secured the prestigious Future Leadership Fellowship, and she has also last year become the chair of the International Association for Travel Behavior Research, the premier conference in our field. But to me, and I've said this to Karishma repeatedly, the thing that stands out the most is her role as a PhD supervisor. She has supervised 12 PhD students to completion in that time in Leeds, so 1 per year. 2 of these have won the very prestigious Eric Pass Award for the best dissertation in travel behavior research. Very few supervisors get 1 student winning it. Karishma's done it twice. There's been over 30 journal papers with those students. And while Karishma has been blessed with having good students, I think the role of the supervisor is very clear to see. So one last point, and I hope my sources are correct. If my sources are correct, then Karishma is the first Bangladeshi professor in Leeds, and also the first female Bangladeshi STEM professor in the whole of the UK. So all that's left to say, well done, and we look forward to more of the same, Professor Choudhury.
I should turn the timer on just a second. Okay, good afternoon, everyone. Can you hear me? And online? Is it okay?
Yes.
Yes, so thanks everyone for coming to the inaugural lecture. I know that everyone is busy, so thanks for managing time for this. And thanks, Stefan, for the intro. I don't think anyone else could have said things in a nicer way about me. Anyway, so in my presentation today, I am going to talk about what I mainly do. And I know that a big portion of today's audience just know that I'm a professor at University of Leeds. Maybe they know I work at transport studies, but not really the detail of what I work on. So I'm going to start with basics a bit, and especially focus on the niche area that I have been working on for the last decade or so. And I also know that there are people here who have been working in this field longer than I have been working in this topic. So for those, bear with me, and I have added some references to the papers below the slides. So if you are interested about any of the topics, I think you will be able to look it up, or feel free to have a discussion with me about it later. So I'm going to start with the pain point of my everyday life. And that is my commute from Ilkley to ITS at Leeds. And in a sense, I'm lucky because there are multiple options. I can drive, which usually takes about 40 minutes, and I park at the free parking spot across the park. So it's a 7 minutes walk to ITS. It doesn't cost a lot on fuel. Or I can take the bus, which takes ages, not too expensive, but requires a 20 minutes walk at the Ilkley end. Or I can take the train, which is 30 minutes. It's not as stressful as driving. So that's the plus, but it's more expensive. And I have to walk 50 minutes, 20 minutes on the Ilkley end and 30 minutes on the Leeds end if I take the train. Or I can cycle. I've never tried that, but it takes 90 minutes and it doesn't actually cost anything. Or I can work from home. So I would like to start by asking you first, given these options, what would you choose to come from Ilkley to Leeds? So maybe those who will drive can raise their hands. Okay. People who will take the bus. Okay, less people. Train. Okay, you can see the majority. And cycle. Highs. Oh, James is here as well. Okay. And I guess the working from home, it's doesn't, okay. Yeah. Yeah, so it does not suit me, but I know some people like it. So now if we think that, so people have different decisions on the same choice situation. So now if we think what actually affects our travel decisions, so our choices are affected by the attributes of the alternatives, like the travel time and travel cost, for example. Then it varies depending on the socio-demographic characteristics, so like age, income, gender. It also depends how much someone cares about the environment. I know that there are people in this room who would never drive, and there are also people in this room who would never take the public transport. So it depends also on the attitudes and perceptions of people about the travel modes. And it can also depend on the experience. So yesterday I took the train, and on the way back, I was delayed by 20 minutes, and it was raining, so my experience was not good. So maybe today I wouldn't have taken the train anyway. And it can be also affected by the emotional state. Like today, I was a bit stressed about this lecture, so I decided not to drive myself. So all these factors basically contribute to our choices. And choice modelers like me, so our task is actually to find the sensitivity towards different level of service variables or attributes like travel time, travel cost, walking time, etc., that different people have and how that affects the choices. So we try to come up with mathematical equations that tell us that how sensitive a person is if the cost increases or if the travel time increases, etc. And these formulas are also inspired by theories from economics and psychology. So we try to use input data and try to calibrate the models or kind of determine the sensitivities so that people can use it for predicting what the same people will do in a future situation. And that is important because ultimately, when there's a new transport project, we are interested to see if people will use it or how people will kind of change their behavior on that situation. So modeling these individual level decisions help us to get to the overall traveler decisions. And then they can be used for policy analysis, sometimes through like these fancy simulation tools, sometimes through other means. But ultimately, they help us to make decisions, like not me, like transport planners and policymakers, like decisions like whether the HS2 should go up to Leeds or stop earlier, or if Leeds should have a tram or not, or Leeds should rather have more bike paths. So these models actually ultimately affect how these planning and policy decisions are being made. So now the traditional way to model this behavior is to use survey data. And this can be interviews, this can be online surveys, etc. But are many problems with these surveys. So for example, like these survey data is subjected to different errors. So when we ask people to report their behavior, sometimes they forget about small trips. Sometimes they round up the time, like maybe they had started at 8:07, but they will say that they started at 8:15. Or they can forget about some of the end trips, for example. That is a common problem, that people forget to report that they have returned home because it's so obvious. The other thing is these survey data are sometimes expensive to collect, especially in developing countries. There's a reliability issue of the data as well. And also, we know that in order to properly understand behavior, we need to look at the behaviors over a stretch of time. But with this survey data, it is very difficult to get like panel observations, what we call them, like that is repeated observations for a person for a month or for a year. So now if we look at the modern ways, so the trip that I made last Friday from Ilkley to Leeds, my Google timeline actually captured it pretty well. That I started from home, I drove to the station, took the train, came to Leeds station, walked up to ITS. In addition, were other apps on my phone. For my driving insurance, there's an app installed which monitors my driving. So it captured my acceleration and deceleration and whether I was going above the speed limit. There was Northern Rail app, which showed actually if the train was running late or not. There was also the Strava app, which showed like what is the pace I was walking in. And I was wearing this wristband, which actually recorded my skin conductance and heart rate, which can be used to infer my stress levels. And these passively generated mobility data sources also include like regular phone data, like when we make the phone call, the tower picks up the call, so there's a digital footprint, Bluetooth, Wi-Fi, CCTV cameras, public transport smart card data, etc. So when I started working in this area about 13, 14 years back, at that time, the era of big data had just started, and people were really interested about this digital traces, mobile phone records, but they were mostly used by data scientists, like visualizing the patterns, trying to see what are the factors that are affecting aggregate level patterns, things like that. Then there was also a trend eventually, like how can machine learning models make use of the big data source sizes of these passively generated data, and they can be used to train the models, the machine learning models, and tell that this person is going to make this choice. But the problem with the machine learning models is it's very data driven. It's a bit like the black box. So we do not really have a good understanding of the behavioral process. And we have done some comparison studies of the machine learning models and the choice models in different contexts. And our conclusion is that if the training scenario from where the original data is and the application scenario where the model is being applied, if there are not a lot of differences, then actually machine learning does better. But if the situation has changed, so for example, in our case study, actually, we were using data from Dhaka, and in between the different waves of data, Dhaka had started using Uber and ride-hailing services. So there was a big change in behavior. And there, actually, the behavior models or the choice models performed better. So that was a motivation to use choice models in these big data sources. But big data has a lot of plus, but it also has a lot of challenges. So the first one is how can we actually infer useful information from this data? So those who are not familiar with the data types, so this is what the data looks like. These are just examples. So for mobile phone, when we are making the phone call, it kind of records it records the ID, but when we get the data, the ID is anonymized. And we get the timestamps, the duration of the call, and the latitude and longitude of the tower that handled the call. So not the actual location, just the tower locations. Or when we are using a smart card data like Oyster card data, it records the ID of the card, the tapping time, tap out time, and the station IDs. So that's all the information that is recorded in the raw data level. But then we can actually use techniques from data science to make use of the data and get meaning out of this data. So map matching algorithms, for example, or just simple heuristics in some cases. So this is an example of the PhD student work done by Andrew Wombale a couple of years back. So he used the mobile phone data traces to model the long distance route choice in context of Senegal. And so this was kind of a long route and people were making phone calls. So we got their phone location traces over a couple of days and we could match them with different routes to see like what route they have chosen. So, but that data sometimes has problems as well. So for some routes, for example, like there are two northern routes, N1 and N2, some records recorded properly which route the person was taking, but some records were somewhere here, which meant that they had taken either northern 1 or northern 2 route, so not one of the southern routes, but we do not know for sure which route they had taken. So that is where the advanced choice modeling techniques helped us. So we actually then used techniques from choice model to account for this uncertainty in the data and come up with models that can handle this lack of precise information for some of the users. Another problem of the big data or passive data is there are a lot of missing information. Like sometimes we do not have the detailed attributes. Sometimes we do not have most cases, we do not have the socio-demographic characteristics. And we do not know what are the options people have, which in a regular survey, we can directly ask. So to give you an example, in the smart card data, in the example I showed, so we had the tap in, tap out information in different stations. And so this was the PhD work of Yu Wang, where he used that data to first infer the residential location of people in Beijing at different stages of COVID. So he was interested to model the relocation behavior that happened during COVID. But the data did not have some of the details that we know also affected people's decision. For example, the size of the flat, the rent of the flat, or if they were sharing the flat with someone, things like that. So what we did was, so he did a supplementary survey, which asked people some of these details, which were not available in the passive data. And then he developed a model which uses both the survey data and the passive data. So the survey data, it was detailed, but it was very small scale survey, whereas the big data was capturing all public transport users, but it did not have all the details. So combining them kind of gave the best of both worlds. And so we realized that there were some common things among the two data sets that enabled us to combine them. And we developed a joint model that helped us to better model the residential relocation decisions. Another problem, as I mentioned, is the data that we get in this passive manner. It is anonymized, so we do not know anything about the user. So specifically, like we do not know, for example, if the person is young or male or full-time working person, things like that. And that is a problem because that means that we cannot capture the heterogeneity in the decisions, which is what we are interested about. So this is also the work by Andrew Wombale, who did the root choice work. So he was looking at how we can account for this problem. And we came up with this hybrid model framework, hybrid in a sense that it had two stages. In the first stage, we were trying to predict about the person in this case, by using their mobile phone call patterns. So we knew that how many people they were calling, when they were making the phone calls, how long were the durations, were they talking during the working hours or later. So that helped us to develop a model that predicted in whether the person was a young, full-time working person or a retired person who stays at home, things like that. And once we had that predicted demographic as output from the first model component, we then used it for the second part, and we used it in the travel behavior models to get our main parameters of interest, which is how these people are sensitive to different factors related to travel. And he validated it with like models, and it turned out that actually it works very well. Now, the other kind of problem, as I was mentioning, is in the passive data, we do not know what the people are choosing from. So in this example, this is a Leeds map, and it shows the shopping areas, the key shopping areas in Leeds. So we were trying to model how people choose, like in which shopping area they are going to go and which travel mode they're going to use. So this was done part of the PhD thesis of Panos, who is here today. So we looked at the data and we tried to see, can we make use of the fact that we have a long set of observations for each individual? So from that, we could infer, or like we knew where there, for example, in this hypothetical case, that this was a person who lived in Biston, who worked at Whitehall Industrial Estate, and regularly goes to a gym on the way to work. And occasionally, they also go to the city center for cinema or to a restaurant, or they visit friends and family in other areas. But we had a good idea about their tour. So on a certain day, what was their origin and destination, and their what we called like the ellipse that they were kind of covering. And we also knew their wider activity space, that is on the full period, what are the other places they were visiting. And so Panos kind of leveraged these information and developed a probabilistic choice model. So this is kind of in layman's word, it is just that acknowledging that people, some people will just choose a shopping destination within their tours. So in this case, maybe they will go to Leeds Retail Park. And if they're considering, they can consider their activity space, that's another possibility. In that case, they would choose the shopping areas that are in the city center and Leeds Retail Park, but not the ones outside. And there can be also, there's also this possibility that some people actually choose beyond these ellipses and just from the whole area. So he accounted that people can be heterogeneous and people can have these different choice sets. And he incorporated that in the choice models. And that helped us to better predict the choices. Now, the other thing I mentioned, that our choices can also be can depend on the experience and the emotional state. So these were not something that were traditionally captured in the models. That is why I put them in a different color. But they were important because one of the things we were interested about, like when we are making the predictions, is actually the transport system is changing very quickly. And so we are expecting that self-driving cars will be available more widely in near future. There may be air taxis in future. There can be hyperloops. These trains basically run in vacuums and are even faster than maglev. Or there can be shared self-driving taxis. So these are just some examples, but the future can be very different from the current present scenario. And we do not know what the future will be. So people do not have any experience of that, but their experience can change their choices that we know from our previous work. So that's where we started collaborating with Virtuosity colleagues, because using VR, we can actually immerse the users in future scenarios so they can experience these future modes, and then they can make their choices. So that is supposed to give us more realistic data about the role of experience in future modes. So, and the additional plus of using this VR is it's done in the labs. So we have control on the scenarios, and we can also collect a lot of additional data. So for example, we can collect physiological sensor data like skin conductance, heart rate, etc., while they're making the experiencing the options. We can use eye tracking to see where they're looking at. We can collect EEG data in not so intrusive manner. So Thomas was one of the first guinea pigs of this headset, and he survived. So we knew that it is safe. So we can collect all this data to try if that can help us to get better models. So this is just one of the examples of the things that we did there. So we were in this scenario, people were initially given textual descriptions of different future modes. That is what is kind of state of practice, that in absence of the modes, we just give people descriptions and we ask people like, what would you choose in that situation? So, but what we did here is, so they made the initial choice, but then they were asked to experience that chosen mode in the VR scenario. So in this case, there was an air taxi. They were waiting, the air taxi came, they took a ride there. And that experience was kind of mapped with what they saw on this table. So if the travel time was short for a mode, they would also have a short trip in that mode in VR. If it was crowded, then they would have that crowding level in the in the VR scenario as well. So we tried to match it as much as possible with what they saw on the table. And then we asked, like, now what would you choose? So that gave us, helped us to capture the effect of experience. Also, our PhD student, Hugh Wang, kind of used that sort of experiments and expanded it to capture, can we actually nudge people in future to choose them public transport? So for example, if the future taxis actually have a dynamic carbon meter that shows, like, as you are traveling, that you are consuming more and more carbon, you're kind of having that carbon output. In that case, will they be still choosing taxi, or they can be moved to a public transport when they're given the choice again? And for that, in addition to the other things, he also is looking at eye tracking data. So here, for example, it gives an idea, the eye tracking data, like how much time the person was looking at this carbon meter, and then we can relate it with their choices. So, and we showed, this is still work in progress, but we see that having the eye tracking data helps us better understand the decisions. Another thing is, I mentioned that we also collected physiological sensor data like skin conductance and heart rate. So we also use them in the models as an indicator of the stress levels to measure, like, if the experience in air taxi, for example, was pleasant or was it scary. So, and if that affects whether they're going to choose air taxi in future or not. So by doing that, we found that actually we get, like, better understanding of the choices. And this was another PhD student's work who worked on collecting EEG data in the cycling context, where the scenarios were different in different runs. And EEG data was collected to get an idea about how much cognitive load was associated with the cycling, and that was used to model their acceleration and deceleration decisions. So right now, so far, we have mainly worked with these passive data sets, except for one field experiment, which we are still analyzing data about in controlled lab conditions. But actually, we can look beyond that as well. Like social media data, for example, also gives us ideas about how people are feeling or what is their sentiment. Then there are now measures like to measure stress from the heat, body heats. Like this was, Thomas forwarded me an article from BBC where University of Sussex researchers found that actually the nose tip becomes cold when people are stressed. So this sort of data are do not even need a lot of controlled laboratory conditions. They can be collected even more easily, or by analyzing facial expressions, we can infer if people are happy or sad. So that also opens up the opportunity that, we can do more things along this line. So just to summarize, so what I have been, I tried to tell in 20 minutes what I have been doing in the last 10, 20 years. But in summary, like I've been trying to leverage these newer kinds of data sources and techniques from data science and ubiquitous computing, like that is the how we measure the stress levels, for example, in the mainstream choice modeling, and better understand the behaviors and ultimately use them in simulation tools so that they can be used for better transport decision making and better investments decisions. And this work, I have mentioned many times that it was done by a PhD student, and actually all my work are done, led by PhD students and the research fellows who are working with me. So I would just like to use this opportunity to thank them for their contributions. And they've made the academic experience much nicer as well. By the experience of working with them was really something I treasure. I also looked a bit at the co-authors I worked with. So I did this word cloud, and I actually worked with 112 co-authors over my career, which I was a bit surprised as well. And so the reason I showed this is, as you can see that, so the person I wrote most papers with is Stefan, and then Thomas Hancock, and then my supervisor, Moshe Ben Akiva. But you will see that a lot of your names are here. So I'm really thankful for you for your contributions in these different works. And it was my research was funded by many organizations. So just I would like to give a shout out to them for believing in my ideas. And just to finish, in inaugural lectures, people are usually also interested to know about the journey or academic path. So I included some things about that. So as you know, I'm from Bangladesh, and I come from the capital city, Dhaka, which is a big mega city. So I've grown up in a very busy city. And I chose to study civil engineering in my undergrads. So one of the things that people usually ask is, how did you decide that you wanted to have academic career? So for me, that was kind of a very natural thing in a sense, because one of my grandfathers was a professor and my father was a professor in civil engineering. And among my immediate family, like my uncles and aunts, we had 9 people who had done PhDs before me. So I think as a kid, it was just a natural thing to do. So the choice was in which discipline I would like to pursue the academic career. And there, I think the environment nudged me a bit towards civil engineering, because my other grandfather was a civil engineer. And when I was young, we went to visit this nice place, and he had passed away at that time. But my father showed that he was the chief engineer of this bridge. The bridge is actually in India now. It was constructed in the British regime in 1932, but it's still standing. And that kind of gave me a bit of awe that, okay, that's a good way to leave a footprint in the world as if you're a civil engineer. And my father was also a civil engineer. So as a high school kid, I used to go with him in one of the major projects he was involved in as an advisory role. And so I was really fascinated about these structures and bridge design. So I chose civil engineering, and that's where I met Zia as well, by the way. But then as I was studying structure, I did not find it that interesting. I felt that it was very saturated and there isn't a lot of new things to contribute. So that's when I became interested in transport, because in Dhaka, we grew up in a lot of traffic problems, and it was growing worse over time. So transport seemed like an interesting thing to work on and improve the state of the city. So I chose transport to do my grad studies. And then there was a bit of kind of luck in a sense that when I was in the final year of my undergrads, I met a family friend who was studying at MIT and working with Moshe in this cool microsimulation project, MITSIM. So he was home for holidays and he showed this to me. And he kind of told me that, with your result, if you apply, you are very likely to get a scholarship. So without actually thinking much, I applied for grad school. And before actually knowing what this simulation involves, because I'm talking about early 2000 when internet was super slow in Bangladesh. It was dial-up internet. So I did not really know what I was getting into, but it seemed like a cool thing. So I went for it. And in my master's and PhD thesis, I was working with driving behavior models. So I was using image process data. So these were like video recordings from tall buildings. They were used to kind of create locations of the vehicles at different points of time. And I used them to develop mathematical models that can predict when the driver will change lanes. And my contribution in this work was that I added this extra layer that it is not only enough to model the immediate decisions. Rather, we need to acknowledge in the models that people actually have plans in their mind when they're making the driving decisions, that they may actually go to a worse lane just because they want to eventually get to a better lane. So, and this plan changes. So my PhD thesis was on the methodological side. It was more about how can we capture the effect of plans in the decisions. And thanks to my supervisor, Moshe, and also my academic advisor, Nigel, who shaped up my ideas. And regarding Moshe, like those who know him know that he is actually very perfectionist. And I was under a lot of pressure during my PhD, but I think he managed to get the best out of me. And the best part of MIT for me was not the research, but rather the friends I made there. So many of them, so these are just a small share of the people I came across in the 5 years at MIT, but many of them are now faculty members in other universities. And we together, we kind of supported each other in our PhD journey in many ways. And also the Boston Bangladeshi community helped me a lot to have the work-life balance. Then after my PhD, at that time, Zia was doing a postdoc, which was 6 months at Cambridge and 6 months at MIT. So I moved to Cambridge and I started working at RAND Europe for 6 months. And that's where I met Andrew. And I also worked with Charlene Rohr, who was at RAND Europe at that time. And I really treasured that time as well, because it gave me a taste of life outside academia and having the weekends free from work, which was nice. But ultimately, I decided that, no, I like academic career more. So then we decided to move back to Bangladesh. And at that time, there was a lot happening in Bangladesh. Like there was the new metro rail was being built. There were elevated expressways. There were plans for BRT. And as faculty member of BUET, this is the same school where I graduated from earlier. So we were involved in peer review role or advisory roles in a lot of these projects. But one of the things that kind of I was struggling is there was no reliable data to develop the models. And that's when I came across the work of Marta Gonzalez, who was at MIT at that time. Now she's at Berkeley. So she was kind of the pioneer at that time in using mobile phone records for modeling mobility. So I got some funding from Schlumberger, Faculty for the Future program, and I spent some time at MIT working with her as a visiting assistant professor. And that kind of laid the foundation of the work I had done later. So we used mobile phone data from Dhaka to develop these models. And then we decided to come abroad again, and Leeds worked well for us because both of us got positions here. And when I first came to Leeds, I only knew Ronghui, Stefan, and Andrew. But in the last couple of years, I'm really thankful for having wonderful colleagues. And especially, I would like to mention the members of the Choice Modeling Center. I'm really lucky that I was here when Stefan was just starting the Choice Modeling Center, and I was able to be a part of it because we all not only had excellent internal researchers, but there were a lot of visiting researchers coming at different points, and it was like a very invigorating, or like it was a melting pot of ideas basically, and it was a very nice thing for an academic. I'm also thankful, especially like to all colleagues, but especially to the female colleagues of ITS, because I have kind of got support from them on different occasions. And one case I especially remember, like Ronghui probably doesn't remember, but I was quite down because I was struggling to find a balance with my baby son and work. And she kind of reassured me, like, it's okay to slow down, you can catch up later. And that kind of really provided the reassurance I needed to move on. And beyond ITS, I was also lucky to get mentorship from Kat and Muhammad Bashir, who is now at Heriot-Watt. He was at head of civil at that time. They helped a lot in terms of, especially in navigating the promotion process. And beyond the university, I always had the academic sibling network, who were previous students of Moshe, and they also always kind of, whenever there was an opportunity and I asked for help, they were always ready to provide assistance. And also the IITBR community, so especially Pat Mokhtarian, because she gave me a lot of confidence in leadership. And she's not only an excellent role model, but I think the way she encourages young female researchers, that's something I learned from her. And then also I have the Bangladeshi transport researcher community, especially this is a picture taken during a TRB. So these are all Bangladeshi female transport researchers in different countries in the world. Most of them are actually my students, undergrad students. So it's really great to see like how they are in different parts of the world now and making a difference. And I'm also very active in social media and Facebook groups, and two groups help me a lot. One is this Buet alumna group, Inspiring Female Buetians. And the other one is Women in Academia Support Network. In many cases, like I have sought advice from these networks on difficult situations, and they have provided excellent advice. And last, I would like to acknowledge that actually the Leeds Bangladeshi community, they made such a big difference in our lives. Like we did not feel like we were away from home because they opened the door for in all festivals, all sorts of occasions, and it's really made our life much more fulfilling. So thanks to them. And lastly, I would like to thank my parents. So my mother actually had to sacrifice her career for me. She was a nuclear physicist, but I was a very stubborn child and a very problem child. So she had to give up her career in order to raise me. And my father, like he always had very high expectations of me. And so I wish he may have been proud if he was here now, but probably he would have found like 10 errors in my presentation as well. And then being a dual career academic is not an easy task. So in addition to the regular ups and downs of academic career, like we have to run what I call a three-legged race, because very often one person has to slow down so that the other person can progress a bit. And thanks to Zia, like I'm really blessed that I had your support in my career journey. And finally, I would like to give a shout out to my son. So when I started at Leeds, this is the photo taken the day before my interview when I first arrived at Leeds, and he was 6 months old. So over in the last, he's now nearly 14, and he had to live in the chaos of the two academics working on weekends, sometimes late hours, and he made the journey very fulfilling. And I'm really happy that when he says that he's proud of my achievements, so he knows that why I work hard and he's proud of it. So that means a lot. Any questions?
Thank you. It's really inspiring. The one that stuck in my mind when you showed your tough choices. If you look at the traditional way of past one diving to first to see that what in public hospital. There must be other limits beyond untouches as well. So, we use in the choice models in the UK right now. Should it be? And if it is, then how to validate that people are actually serious?
We need to acknowledge this the bias sample. So, like, maybe not everyone can. But if we just run the gene, choose to assign that time has changed now. So I think we need to get knowledge. Validation part is tricky because we are working with a situation that is evolving time. So, but I think even if you take data for a couple of years and that can be if the trend is what we find from the survey. Probably let Dia start and we can have more questions.
Not sure if this microphone's working, but okay.
Yeah.
So I've got the pleasure of introducing Zia, the second half of this power couple. But before I do that, I just thought maybe one question. I noticed in your choice set for your travel to work, there wasn't an option, travel with Zia. Now, oh, okay, yeah. Yes, right. We were wondering whether you discussed research all the time, you know, maybe just on your commute. Okay, so my pleasure to introduce Zia, Professor of Mobility and Energy Futures, mixed between Institute for Transport Studies and the School of Chemical and Process Engineering. Now, Zia takes a less specialist approach, looking at interactions between transport, energy, environment and society in a multidisciplinary setting. And again, a range of topics: vehicle automation, sharing, electric vehicle adoption, aviation, transport energy poverty, low carbon transitions, both in developed and developing countries. So I think he takes a different angle than many others when you read his papers. And again, if you haven't read his papers, you're probably not on LinkedIn. I mean, Zia is the master of promoting papers. I just remember thinking, you know, I don't remember the first time I came across Zia, but I just remember hearing this person. He's had 10,000 downloads on one paper. What's happening? How do you do that? Sorry? 50,000. Oh, well, maybe it was your first paper. But yeah, Zia, again, has come from Buet, he's at University of Melbourne, Imperial College, and held academic positions, as you mentioned in your presentation, also at Buet, Cambridge, MIT, and now Leeds. I don't know if you're a competitive family at all, but it says here he's produced over 80 journal papers and had 6,000 plus citations. And he does work, as you say, internationally with people in Bangladesh, India, Uganda, Nigeria, China, Germany, etc., etc., and has held various positions at TRB and UTSG. But again, similarly, he's also interested in PhD students and his current role is head of doctoral college for our faculty, looking after those PhD students. So, great pleasure to introduce Zia, and I look forward to hearing your different angle on the world.
Thanks very much, Simon, and thanks everybody for coming. So you may have noticed that I have changed the title a bit from Mind the Gaps, Transport Transition toward Net Zero to Minding the Gaps, because I think it's more of the story I'm about to tell is more about how I have minded the gaps and how I have tried to mend some of those gaps in transport transition toward net zero. I had to put up this picture because my mom went a long way to find an album, an old album, and find this photo of me in Bristol when, I don't know, I was 1.5 years old maybe. So we were here for 6 months. And the really interesting thing is, look at the trousers. Look at my jacket today. It's still the same design. So it looks like I haven't really changed much, except from losing some of the hair, I guess. My journey, academic journey started at BUET, again, as a civil and structural engineer, actually. And like Karishma, I also was in the later half, I got more interested on the transport side of things. I did a master's in University of Melbourne, where I worked on a project on transport emissions, and that kind of piqued my interest in transport emission side of things. Especially, we always wanted to go back to Bangladesh and work there. So the focus on air quality and emissions from transportation, those were really important, and no one was actually working on the area. But that gave me this interest in transportation sector, sustainable transportation sector in general. Then I did a PhD at Imperial College London, as Stefan has already said. Then 2 postdocs at University of Cambridge and MIT. And then, as Karishma said, after the MIT postdoc, we went back to Bangladesh again for a few years, and then moved to Leeds and have been here ever since. So that's kind of my journey very briefly. Back to the main topic today. I'm sure we all know that transportation is one of the largest sources of carbon emissions. So we all know about climate change and the likes. So I wouldn't bore you with data around that, but the key point is that we really need to decarbonize transport. Almost 1/4 of emissions are actually coming from the transport sector globally. And this is a framework that I use. It really helps me organize my thoughts. Okay, this is a very simple framework, carbon emission, and this framework can be used in various different ways. You can make it more complicated, add a few interactions, but at its heart, this is really useful, almost like Transport Energy 101. I actually showed this picture in my class as well. So very simple. Carbon emissions, say at a household level, is a function of how many miles you drive, multiplied by how fuel efficient your car is, miles per gallon, multiplied by what fuel your car is using, right? Whether if you're using petrol versus diesel versus electric car. And this can be done for car. This can be also done for many other modes, right? In modeling sense, you just add a summation there and model the summation over I, J, K, and the likes. But you can add all different sorts of travel modes, different types of how energy efficient they are and how carbon intensive they are. And there will be various interactions between these 3 factors. The key among them that's discussed a lot nowadays is rebound. What it means is that if you work with, if you make your vehicle more energy efficient, that makes your travel cost lower, per mile travel cost, and then you may start driving a bit more. And that's a big thing in the context of electric vehicles, because we know that running costs for electric vehicles are significantly lower. And you could have other interactions within that as well. Now, obviously, this doesn't sit alone. It sits within a context, within a city context, within regulation, a regulatory context, policy context. And policies can affect, you can have policies that affect each of these items directly, the emissions or any of the travel behavior, energy efficiency or carbon intensity side of things. And if you introduce a policy to address any one of them, it will affect something else as well, right? So wider impact. Rebound is also kind of a wider impact to some extent. How does it affect other areas as well, not just carbon emissions? We sometimes get too bogged down with carbon emissions. And that is something that I am quite interested in as well. So throughout my presentation, what you'll see this framework at the top or bottom corner, and I'll mark which area I'm addressing that specific research. Okay, so to begin with, so the 5 gaps, I'll be talking about 5 gaps that I have identified in my career, and I tried to address. The first one was equity. Just transition is something that you hear a lot in terms of decarbonizing, not just transport, but others. When I started my PhD, I was really fascinated by the idea of personal carbon trading, that everybody will have their own carbon quota. If you do not use your quota, you can sell your quota. If you're environment friendly, then you'll have excess quota. If you're using those large SUVs, you're probably above your quota, and then you'll buy the quota from the person who is saving their permits. And it was really fascinating because this kind of tackles one of the key challenges, which is equity. People who are traveling in an environmentally friendly manner, they are actually benefiting from the policy. People who are emitting more, they are actually penalized for the policy. So this addresses directly the equity and justice side of things to some extent. Now, that's what my PhD, and I had another small project as well later from European Union on this topic, but this is obviously something that is difficult to implement in the Western world. Having a carbon budget is really difficult in this part of society. And actually, China is doing quite a bit of research in this area now. So I didn't show any results for this one. This was just my PhD and a few kind of an interest in the side. But the area that I got really interested in after I came to Leeds in terms of decarbonization and reducing carbon emissions in transport is driverless cars. And there's a backstory for that. So we moved in 2012 in Leeds, and I didn't know how to drive, right? I was in London, in Boston, in Cambridge, in Melbourne, very good cities with very good public transport. And I didn't need to learn driving. But after Karishma and Asha's moved, Asha was, I think, only 1 year old, I did feel that we now need a car. We have to drive, and I have to start driving. Just as Karishma said that when she is stressed, she lets me drive, passing on the driving duty to me. So it was like that as well. She's stressed with the kids, so I have to learn driving, which is fine. But I failed my first driving test. That was probably the first exam I ever failed in life. But I failed, and I was quite upset. I was quite upset, and I didn't want to go for another exam. And that's when that first video, if those of you remember, the first video of the driverless car came out around 2013-ish, that a visually impaired person is driving these fully driverless cars. And I thought, okay, I want them tomorrow. That was my view. And that got me thinking, like, hold on a second. Right now, I don't drive, so my carbon emissions, I'm very environment friendly in that sense. But now I want this car, and there must be other people like me who'd want this car as well. And those are not, my case was unique. I learned driving obviously very late, but elderly people, disabled people, they would really find these cars very useful. And that would mean that travel demand could go up. And that could, that's one of the sides of things that I showed. It could actually derail some of our decarbonization goals. So that's when I really got interested and started reading a bit and started working on this topic. So at that time, I'm talking 2014 now, 2013, 2014, this was kind of the headlines, like driverless cars are going to solve all our problems. And there are good papers. This is not just a newspaper headline. I think this was behind, they were citing a professor from Berkeley at that time. Okay. But the literature you see at that time, the sparse literature that was coming out, they were all focusing on on these two sides of things. Does that mouse show? Yeah. On the engineering side of things, on efficiency, on electrification and stuff like that. No one actually thought about that travel demand side of things. And we thought, hold on a second, that is going to massively change traveler's cards. It's actually have more change on the travel demand side than probably energy efficiency and the carbon side. So we came up with what we call a qualitative framework to a ripple effect diagram, trying to understand what automation and connectivity does. Right? They do not change travel behavior immediately. It's not a first order effect. The first order effect is that they make traveling safer. They probably will allow infrastructure to have more capacity, allow technological innovation. But also they will make traveling more convenient. Driving is not stressful anymore, right? And that means that your travel cost, however you measure it, it doesn't always have to be measured in terms of pounds, goes down. And that have knock-on effect on how you travel, right? And so so we have done some work, we have looked at the literature, done some small bit of modeling work and developed several scenarios of this driverless car into the future. And we did see that in at least a few of the scenarios, the travel demand was increasing so much that all of those energy efficiency gains were getting lost. And this is where, so we published our paper. That's the one that Simon was mentioning. It was downloaded, I think, 50,000 times at that time. They don't put any statistics anymore now, but anyway. So it got quite a bit of press support actually throughout the world. And obviously, this is my most impactful work to date. I'm really pleased because we could change the narrative. That's why this was important. Until this paper came out, people were all saying, oh, automation is going to solve our problems. But we changed that narrative and said, hold on a second, we need to be really careful about how these vehicles get used. Now, this is, of course, a very relatively broad framework. We didn't know individually how to model each of them, but that's what I got interested in later on. Moving on from here, we thought like, okay, one very important parameter is value of travel time saved, right? So the stuff that Karishma, Richard, Stefan, they work on. But nobody has done any work on how the value of travel time will be changed in a driverless car. And also behind that is how you use your travel time. That is also very important, right? And all of them may lead to whether you will own a driverless car or whether you will use an automated robotaxi type thing, an automated Uber type service, ownership versus share. These are the items we felt where we really need to get ahead of. Otherwise, we cannot really say what's going to happen. We cannot reduce the uncertainties. So the next bit of work that I'm quite proud of actually, because we wanted to look at the usefulness of travel time in driverless cars, not value of travel time, but how people will use what will people do in these driverless cars. Now, there has been work done by Glenn Lyons, I think before me, in terms of travel time use in trains. Now that is relatively easy to do because, you know, as a train passenger, you do work, we go and survey people and ask, what have you been doing in your train trip? You get those data and it's easy to do. What do you with the car? Because if you ask people, what do you do in a car? The only answer will probably be, I'm driving, I'm listening to music, I'm talking to maybe fellow passenger. If they're doing anything else, they're not going to tell you that, right? So this is where my Bangladeshi route became really useful. I went to Bangladesh. And what we did is, it's very common to have chauffeur-driven car there, right? So an automated car is like a chauffeur-driven car, right? You are not driving. It's your car, but you are not driving. You have your own space at the back and things like that. And we asked people, what do you do in your car now? And then we have some grounding of, okay, these are the type of activities what people might do in an automated car. And interestingly, we also did a survey in the UK, US, and we asked people, what will you do in an automated car? And I wasn't frankly expecting much correlation. I think there was some correlation, but they were very highly correlated. The activities that people say they do now in a chauffeur-driven car in Bangladesh are similar to the activities that people in the US and UK, which is a very different country, which are very different countries, that they would do in an automated car. I think the main difference was in Bangladesh, people didn't say that they will read a lot, whereas reading was a bit high in this part of the world. So that chauffeur-driven analogy was really interesting, and I felt, and quite innovative at that time. The third item, I think the third gap is about owning versus sharing. This is related not only to driverless cars, but also in the context of Ubers, right? This ride sourcing services, how they have changed, how we travel, and the likes. And this is where I got interested in the value of ownership, or value of sharing, or value of inconvenience of sharing a car. In transportation, the value of travel time saved is a very common one, valuing travel time, valuing wait time, valuing in-vehicle time, valuing comfort and the likes. But we wanted to know, okay, how can we separate like the inherent how can we value the inherent attractiveness of owning a vehicle versus possibly the inherent inconvenience of sharing it with someone, like that. And this is where my in-house choice modeler wife came in quite handy. She didn't do too much, but she did give me advice in that sense. But also, I worked with Fanny, who used to be a postdoc here on this type of work. And we actually did find that people do value ownership positively, like they value owning a car, and versus they negatively value sharing, right? So there's a lot of talk about sharing a vehicle, not just in a driverless context, but in an Uber context. But it's not an easy transition. Okay? People just don't like to share. And we derived some how people might using UK data in the future. Yes, you see that ownership will fall when the driverless cars become popular, because you can take the Uber driver out, and then per mile cost becomes much cheaper, and it can get better. But also, it's still almost around 50% people were still for them owning was still the least costly option. So exclusive ride and full ride is good in this sense, but this is where I got to move a bit from driverless cars to the Uber type of ride-hailing things, because now I got interested in energy efficiency. If you have the same car, the Uber trip will be less energy. Even if you have the same car that you own and you take that type of a car for your Uber trip, it will still be less efficient, because Uber will have a lot of empty trip, right? In your own car, you go from your home to your office, and that's it. On Uber, it picks you up from your home, goes to your office, then it runs empty to pick up the next passenger. And we had some access to some GPS data, tracking data from the US, and we found that this can be as high as 50 to 60%. Right? So your energy efficiency will be significantly lower if you switch to from an ownership to an Uber type service. There are other subtle advantages of Ubers. I wouldn't get into too much detail, but the key here was that if it's an exclusive use Uber type trip, exclusive use mobility service, then you're not likely going to gain anything from your modal switch. It has to be pooled. It has to be a shared trip, which is not common in the UK. In the US, you see quite a bit of Uber pool. I think in London, they had Uber pool before COVID, but they probably do not have it anymore now. But the sharing that trip is really, really important. And when I got into Uber, the next thing I got interested in is effect of Uber on ownership. Uber, Lyft, they were saying all the time, oh, we have reduced vehicle ownership in the US here and there. And I wanted to really investigate, is that true? So the first study that we did was in Dhaka again, and this is not on Uber, typical Uber, this is what called Uber Moto, motorcycle ride hailing services, right? And we got interested. And what we found that, so what this picture shows very simply is that this dashed line is what the motorcycle numbers should have been if Uber Moto wasn't there. And that is basically, this is when the Uber Moto was introduced. Okay. And this blue line is actually the actual number of motorcycles. And you can see clearly that the actual numbers have gone up. Now that in itself, those of you in economics, they will say, oh, that doesn't prove causality, right? So we had to have a counterfactual, which was Bangladesh, where Uber Moto is still, rest of Bangladesh, where Uber Moto wasn't still there. And this is where you can see that our predicted ownership and actual ownership were at the same level. The difference in Dhaka was that Uber Moto, the ride-hailing services had started there. So this showed that ownership has actually gone up in Bangladesh. Any guesses why? Why would ownership go up? Motorcycle ownership. They are substitutes, right? Say typical Uber is a substitute of a typical car. So you'd expect car ownership to go down generally. Yeah. Yes. So there's huge differences in context. In Bangladesh, people were buying motorcycles to put it into service as a job for their livelihood, right? And that increased. And that's something you see in other places as well. In Mexico, one of my students had a look. They found that. But in the UK, we did find that ownership has been falling a bit since the start of Uber. And then we wanted to look at UK's more detailed data. These were aggregate data, but we wanted to look at UK's more detailed data. Understanding society follows households in the UK. Some of you already use this data, the others who do not. It follows households in the UK at various times. So we wanted to see what happens when Uber has entered in their region in those households. What we found is that people actually do not give up a car. So if you're owning a car and Uber becomes available in your place, you do not just get rid of their car. But what we see is that people stop acquiring the next car. Okay, if you have one car, you do not acquire the second car if you live in an area where there's an Uber. So it does show that the mechanism kind of how car ownership could be affected differently in different places of the earth. So that's an area we really need to understand quite well in terms of ownership and sharing. The fourth gap I wanted to touch on is on competing goals. And so far I came to transport not via typical path, studying transportation and going there. I came from a very transport energy side, and I'm getting into transport side now. So electric vehicles are obviously a big thing now, but there are other transport systems goals, right? Our only goal is not decarbonizing transport. There are other goals, reducing noise, safety is a big goal for sustainable mobility. Congestion is another one, reducing congestion, and improve accessibility is something that is also really important as goals of the transportation system. And not just electric vehicles, but various, any new technology in the transport era or even in other domain can affect these areas as well. And we really need to be aware of these competing goals. We shouldn't think only silo. There are plenty of examples in transportation where we focused our effort in one direction only, and then in other areas, things didn't go well. Dieselgate is an example, right? We focus everything like diesel reduces carbon emissions, focus on that. And now we see what it really aggravated air quality. Thinking about electric vehicles and larger goals, let's see, safety I'll come back to later. Just let's look at this picture. You replace all of these cars with electric cars, nothing really changes, right? The congestion is there. Actually, there is a risk of increasing congestion because of the rebound effect that I have mentioned earlier. So we really need to understand those things. This picture is from Dhaka. You replace this bus by an electric bus. It doesn't really change. These 4 people at the background here, they will still have difficulty getting into the bus. Not only that, you spend a lot of money to buy expensive electric buses, which means your fund, which is very limited, especially in developing countries, is diverted from improving this system because you're narrowly focusing only on your electric vehicles. Okay, so these are the things I think we really need to be aware of going forward, especially in terms of EVs. Even for carbon emissions alone. So this picture shows what we call the grid carbon intensity. How much carbon is emitted to produce 1 kilowatt-hour of electricity. Now, look at Norway, Sweden. Most of their electricity come from hydropower. Fantastic. Very low carbon, 0 carbon almost. So switching your petrol and diesel vehicle to electric vehicles makes sense there, right? Because you will make a lot of benefit there. UK is doing quite well here, between 100 and 200. But there are plenty of countries in the world, especially in the developing and emerging economies, where the grid is not decarbonized yet. Okay, if you are between this region, so break-even, electric vehicles break-even with petrol will be somewhere around this region. So anything above that, if you switch to an electric vehicle, that is actually worse than driving your petrol vehicle or diesel vehicle. So we really need to be aware of that. And a lot of these countries are still developing. So the household electricity demand is going up, industrial electricity demand is going up, and coal looks like the only solution. Even if I look at Bangladesh in the last few years, I think the big power plant that came up was coal powered. Okay. And that means the additional electricity is coming from coal, right? So that's not good for electric vehicles either. So we really need to know where we are electrifying and when we are electrifying. That is something that I'm quite interested in going to the future, optimization of these things, making sure that we are transitioning at the right time. Let's not forget electric vehicles are expensive. And the third W here is which type of vehicles. A lot of discussion here in this part of the world is about car. But in that part of the world, motorcycles are really common and they are quite polluting as well in terms of air quality, not good. Same with three-wheeler vehicles. So they are huge in number. So maybe we should focus on those areas compared to electrifying car. Okay. EV safety is something that piqued my interest only last year. I haven't done any accident collision research before that. But there was this paper which came out last year saying that electric cars more likely to hit pedestrians than petrol vehicles. And again, a good journal paper coming from London School of Tropical Hygiene, that one. It's a very good school. And I got interested in this topic then, and we looked into UK stats data, and I tried to find out why EVs could be bad. And there are reasons. EVs are quieter, right? EVs are heavier. So if an accident takes, so EVs are quieter, that might increase your accident rate, collision rate. But EVs are also heavier. So if a collision happens, then you are likely to get more severely injured if you are hit by an EV. But also, if you look at EVs are much newer, right? The EVs that are flying on the road now, they are much newer as compared to an average petrol car or an average diesel car. And that means that they have much better safety facilities as well. And we looked at the data, and it actually does show that, yes, early on, EVs, so this is the pedestrian casualty rate, or billion vehicle mile. Early on, EVs were a bit bad. Hybrids were quite bad actually. But around from 2019, EVs are at par with petrol and diesel vehicles. So if anybody tells you that, oh, no, EVs are unsafe, you can confidently say that, no, they are not unsafe. Not only the collision rate, we have also seen that even in the case of a collision, EVs, the injuries are no more severe than petrol-related injuries, petrol or diesel-related injuries. So that's another of my kind of myth-busting, research-busting research. EVs safety is not, it's not just a topic in this part of the world. Again, going back to my roots in Bangladesh, these used to be the middle picture. These used to be pedal rickshaws you may have seen in India and other places, right? These used to be pedal run rickshaws, but many of them, I think majority of them have now switched to electrification. They use lead acid battery, the box that you can see here. Okay, these are lead acid batteries. Now these vehicles are really dangerous now because they are now heavier vehicles, right? They are much quicker vehicles, okay? They can drive much quicker. But the brake they're using is those old friction brakes. It is like that, oh no. So this has become a huge challenge. And people are just creating vehicle designs out of nowhere in garages. There's no regulatory oversight, nothing. So that, and you can see that they are not safe, not even stable. So that is going to be a big area, I think, and I'd be very keen to work on developing countries in this area. Foregone, the last one I wanted to just touch very briefly on is on urban versus long distance travel. A lot of the debate around carbon emissions you'll see in the transport area is about how to switch people from our cars to buses, from our cars to cycle, from our cars to walking, which is all good. But we wanted to understand, okay, where is long distance travel in this discussion, right? So we went back and we tried to understand, okay, what's the mileage distribution in the UK using various data sources. And what this shows here, for example, say between 2 to 30% of our, 25% of our trips, 20% of our passenger trips are between 2 to 4 miles. Okay. But because these are small trips, as a whole, they cover only 4 to 5% of our miles, and same as our emissions. The further you go down towards your right, you know, the trip lengths, individual trip lengths are increasing. And you can see that mileage contribution are going. So you cannot even see any green here, right? So very few trips, but very high mileage, right? On top of this, especially at this end, this will be flying, which means that they're even worse in terms of their greenhouse gas emission performance, right? So we have done some numbers here, and roughly 3% of our trips, passenger trips, are long distance. By long distance, I'm defining it as more than 50 miles one way. Can anybody guess what percentage is the miles, those 3% trips? What percent of miles are they responsible? You have seen this presentation, you cannot speak up. What percent of miles and emissions? 3% of trips, 60% of miles, 70% of emissions. We expected it will be high, but I was thinking with 3 and maybe 50-ish. 70% of emissions are responsible, but we do not do enough in that area. Why does it matter? Going back to the initial example, okay, we have done a thought exercise. Let's say we move all our car trips less than 8 miles to bicycle and walking. That will reduce your emissions by 9%, not an insignificant amount, but that would mean 55% of the trips needs to be moved. Billions of trips we are talking about. Do it here at a long distance level. Move some of the flying trips to rail. less than 1,000 miles is doable in rail. You are still at the same order of magnitude reduction, but very few trips gets affected. I'm not saying it's easy, because those few trips people will cherish for their one foreign holiday and things like that. I'm not saying it's easy, but just looking at it from kind of an efficiency metric side. So we coined a term, emission reduction sensitivity. We defined it by dividing this by this. And you can see the more you target longer distance, the better benefits you get actually in terms of less disruption in terms of number of trips affected. And so these are the 5 areas that I think are still really important in terms of decarbonizing transport: equity and justice versus efficiency. Driverless cars, still a lot needs to be done. I don't work on the technology side, of course. I assume they will work. Owning versus sharing still there's a big debate out there and very much context dependent. As I say, competing goals is we need to be aware of, so that we do not just focus only on decarbonization and then start neglecting other areas. And urban versus long distance is something that I will explore a bit more in the future as well. The journey wouldn't have been possible without the really talented PhD graduates I have had, 13 in total, all really good. My one regret is probably nearly all of my PhD students have turned to the dark side. What I mean by that is they did not remain in academia. I think only 2 of them remained in academia. Others have gone on to work for industry or government. The co-authors, I don't have 112 like Karishma, but I had 70 or 80, but my son could put in 50 of them in this collage. 3 persons I wanted to mention, especially one is Professor Sorabuddin Ahmad, who was my undergraduate thesis supervisor. I think she was your supervisor as well, right? Yes, yeah. He really introduced me to writing papers and doing really good research, getting me interested in good research. Second one is Bob Nolan, my supervisor at Imperial, now at Rutgers. He asked me to ask questions. So because I was switching kind of from structure to transport directly for my PhD almost. Anything I read on the papers, I was like, oh, that has to be absolute truth, right? But he gave me the confidence to ask questions. No, question everything that you read. And I think I still have that. Ashma says that sometimes they ask too many questions, but anyway. And the third person is Andreas Schaefer, who was my supervisor when I was doing the postdoc at Cambridge, now at UCL, and he has been like a mentor to me, external mentor. And I'm quite grateful to all of them, all the authors and co-authors. You will have noticed one important person is missing in this co-author list, but she's in this one, right? So we have co-authored people who have been asking. We have co-authored two papers, not too many. So this is my lovely family. Obviously, Karishma is there. Ashaz is over there. My mom is not here right now, and my sister is there. She is also a postdoc at Leeds, so we are taking over university. Okay, be careful. And now a bit of a fun thing. So how is it to live in a transport researcher family? So this is a Scrabble that we were playing when Ashaz was 6-year-old. And Karishma and I were saying, no, TRB is not a word. It's not a word. And he was saying, no, but you and Ma always talk about TRB. It has to be a word. So that's how it is in the family. It's not all research. Of course, we've tried to fill our life with color as well. Thank you.